Here we have a SAT math problem. Okay, let's go the question. The measure of angle BDC in radians is equal to A pi over B, where A and B are constants. What is the smallest possible value of A plus to B? Okay, in this problem, our first work is to get the measure of angle BDC in radians. Then I will be getting it in this form A pi over B, from which we can get the values of the constants A and B. From the values of the constants A and B, we can get the smallest possible value of A plus to B. Okay, here first let's find the position of angle BDC in the given figure. Okay, so this is a position of angle BDC. So here, and we have one more position for angle BDC, that is over here. So both the angles are marked over here represent the angle BDC. So we have to get the measures of both the angles. Once we get the measures of both the angles, we have to write them in radians, particularly in this form. Then we can get the values of constants A and B. Okay, now let me draw a radius to the circle from the center D to a point A on the circle. So the line segment I have drawn over here represents the radius of the circle, and already we have two more radius in the given figure. There is line segment BD and the line segment CD. So BD, CD, AD, all of them must be equal in length because all of them represent the radius of the circle. Okay, now what we can do is we can consider the triangle ABD over here. It is an isosceles triangle because two sides are equal in length. In an isosceles triangle, the two interior angles which are opposite to the sides of equal length must be equal in measure. Now let me consider the interior angle over here and interior angle over here. Both the interior angles are opposite to the sides of equal length, AD and BD. So these two interior angles must be equal in measure. Already we know the measure of this interior angle, that is 19 degrees. Then the measure of this interior angle is also 19 degrees. Now let me consider the triangle ACD over here. This is also an isosceles triangle because two sides are equal in length, and the same thing, the two interior angles which are opposite to the sides of equal length must be equal in measure. That is, this interior angle must be equal in measure. Already we know that this is 90 degrees and the measure of this interior angle over here has to be 90 degrees. Then what is the measure of this angle over here? For that we have to add this 19 and 19. When we add them, we get 38 degrees. Okay, now let me mark this angle 38 degrees. Actually, this is the angle subtended by the arc BC at point A on the circle. Now, let me consider the angle at the center over here. This is the angle subtended by the same arc BC at the center. By theorem, the angle subtended by an arc at the center is 2 times the angle subtended by the same arc at a point on the circle. So now, to get the measure of this angle, we have to take 2 times of this angle. 2 times of 38 degrees is 76 degrees. We know that the angle of one full rotation measures 360 degrees. Here we have angle of one full rotation. It measures 360 degrees. So the part of the full angle over here, that is 76 degrees. Then what is the measure of this angle? To get the measure of this angle, we have to subtract the 76 from 360 degrees. Then we get 284 degrees. Okay, as we have discussed already, we have the position of angle BDC at two places in the given. One is over here and the other one is over here, and we got the measures at the both the positions. That is, measure of angle BDC equals to 76 degrees, and also the measure of angle BDC equals to 284 degrees. But we have to get the measure of angle BDC in radians. Okay, how do you have to convert these angle measures in radians? Because these two angle measures are in degrees. Now to convert them to radians, what we have to do is we have to multiply each of these angle measure by pi over 180 degrees. Let me do the same thing over here. And the greatest common divisor for 76 and 180 is 4. That is, 4 goes into 76 19 times, and 4 goes into 180 45 times. Okay, now let me do the same thing over here. So the greatest common divisor for 284 and 180 is 4. 4 goes into 180 45 times, and 4 goes into 284 71 times. Okay, here we get 19 pi over 45, and here we get 71 pi over 45. Okay, now I got the measure of angle BDC in radians, and also both the angles are in this form, A pi over B. When I compare this one and this one, I am getting A equals to 19 and B equals to 45. When I compare this one with A pi over B, I am getting A equals to 71 and B equals to 45. Okay, our aim is to get the smallest possible value for A positive B. Okay, in both the cases, we have the same value for 45. In the second case, the value of A is bigger than the value of A in the first case. So we'll be getting the smallest possible value of A past B only in the first case, because here A is smaller. Okay, so A past B equals to 19 positive 45. Okay, when I add 19 and 45, I am getting 64. Therefore, the smallest possible value of A past B is 64.